Welcome to IGCSE and A-level chemistry classes. In this video, we are going to discuss about past paper 4, questions related to organic chemistry. Okay. So here, June 2007, question number 7. See here, this question related to ester. Here one structure is given and you have to write which type of alcohol and carboxylic acid used to make this ester from this structure. Okay, before answering this question, you just understand basic idea about carboxylic acid and ester. First one, carboxylic acid. Carboxylic acid. Here, the functional group of carboxylic acid, carbon double bond oxygen, single bond OH. This is carboxylic acid. Okay. Example for carboxylic acid, CH3C double bond oxygen OH. Carboxylic acid. Here 2 carbon and this is ethanoic acid. This carboxylic acid also you can write like this, CH3COOH. This is carboxylic acid. Okay. Another one, alcohol. Alcohol functional group OH. The compound which contain OH functional group, that is alcohol. For example, CH3OH. Another example, CH3CH2OH. Here 1 carbon and OH, it is methanol. Here 2 carbon and OH, it is ethanol. Ethanol. This is carboxylic acid. Carboxylic acid functional group COOH. CH3COOH, it is ethanoic acid. Here another thing you have to understand, alcohol and carboxylic acid react together in presence of concentrated sulfuric acid, it form ester. For example, here you have CH3C double bond oxygen OH, it is ethanoic acid. Ethanoic acid reacted with the CH3CH2OH. CH3CH2OH mean it is ethanol. Ethanoic acid and ethanol, both of them reacted with the concentrated sulfuric acid. Ethanol and ethanoic acid react together in presence of concentrated sulfuric acid, form ester. Will be formed. Okay. Here concentrated sulfuric acid used as dehydrating agent. It helps to remove water molecule. So here this OH and from here this hydrogen will be removed. Rest of the part we can write like this, CH3C double bond oxygen. Then here, then you have to complete OH removed, hydrogen removed. So this part we completed already. Then we had to join this part, oxygen, CH2, CH3. This type of compound is called ester. So in this ester, this part came from carboxylic acid. This is carboxylic acid. This part came from carboxylic acid and this part came from alcohol. Okay. Now come to this question. This is the structure given. Okay. This is the structure in the question paper. You have to complete what type of carboxylic acid, what type of alcohol used to make this ester. Here 2 carbon, CH3C double bond oxygen, this is This is carboxylic acid part, and here this part is alcohol part. Okay, so you have to say CH3 C double bond oxygen OH, CH3 C double bond oxygen OH, ethanoic acid. This is carboxylic acid, ethanoic acid. And the ester part, here CH3 CH2 CH2 CH2O OH, it will be alcohol. So CH3, look here, CH3, after CH3 1 2 3 3 CH2 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 CH2, it came 3 times. Okay, CH3 CH2 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 OH. So what is the name of this compound? How many carbon here? 1 2 3 4, 4 carbon. So it will be butanol. Butanol. Okay, so this compound is made of ethanoic acid and butanol, and you can draw the structure like this. You can draw the structure like this. Okay, CH3 C double bond oxygen OH, or you can do like this, CH3 C double bond OOH. And this is butanoic acid, 4 carbon, 1 2 3 4, CH3 CH2 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 OH. Clear? So these are the compound. Here we have to complete all hydrogen. Okay. So that is the question asking. Here we are given this alcohol, this ester. This ester is made of ethanol, ethanoic acid and butanol, and we have to draw their structure. I show over here how to draw the structure. Clear? Part B, same question. Here we have to draw the structure of pterylene. Draw the structure of pterylene. Okay, so here pterylene is one example for synthetic ester. There are different type of ester: natural ester, synthetic ester. Okay, example for natural ester, oil or fat. Synthetic ester, pterylene. Pterylene is example for synthetic ester. It is man-made, and we have to draw the structure of pterylene. Look here how to draw the structure of pterylene. Here pterylene is ester. I told you before, ester is made of alcohol and carboxylic acid. Pterylene, which consists of this type of alcohol and carboxylic acid, dialcohol and dicarboxylic acid. Dialcohol means the compound which consists of 2 OH functional group, 2 OH. That's why we call this type of alcohol dialcohol. And this is dicarboxylic acid. Dicarboxylic acid means the compound which consists of 2 COOH group, that is dialcohol and dicarboxylic acid. Clear? Look here, these two compounds combine to form pterylene. I told you before, when we make ester, from carboxylic acid OH and from alcohol hydrogen will be removed. This hydrogen and OH combine to form water molecule. Water molecule will be eliminated. Okay. And also from here this OH and this hydrogen will be removed. Okay. And it is not single molecule, polymer. Pterylene, it is polymer. This type of n number, many number of dialcohol and many number of dicarboxylic acid join to form a long chain polymer. It is long chain, not single molecule. Okay. So Look here how to draw the structure of pterylene. Here hydrogen removed. So what is left? Oxygen, CH2, CH2, oxygen. Here OH removed. So what is left? This bond is directly going to carbon because there is no OH. And here this type of ring structure is called benzene. Benzene. Okay. Carbon double bond oxygen. Here no OH. OH removed. So this is the structure of pterylene. This is the structure of pterylene. Pterylene also called another name of pterylene Dacron. Dacron also another name of pterylene. Okay. So here you just understand, you have to remember these are the monomers of pterylene or dacron, dialcohol and dicarboxylic acid. Dialcohol mean the compound which consists of two OH group. Dicarboxylic acid mean the compound which consists of two carboxylic acid, dicarboxylic acid, dialcohol, the compound which consists of two OH group. They will join together form ester pterylene. Okay, so this is the structure. Same structure we can show another way. This structure we can draw another way. Look here. Instead of this CH2, I will show over here one box. Okay. Oxygen, oxygen, carbon double bond oxygen. Here it is another box. This benzene ring, another. See here it is CH2. This is one compound. Here it is benzene ring. These are not same type of compound. These are different type of compound. That's why I am showing here different type of box. Clear? This is CH2. Okay. And this is benzene ring. These are different type of compound. That's why I am using here different type of box. You can use shaded box over here, empty box here. It is doesn't matter. You can change it, but we will use different type of box. Clear? So here oxygen, this box, again oxygen, carbon double bond oxygen, another box, then carbon double bond oxygen. So this is another way of representation of pterylene or dacron. Pterylene or dacron. So this box means CH2, another box means benzene ring. You remember this. Clear? Here this is the structure. In different questions, sometime in question they will give you this type of structure. You have to draw the structure of monomer. This is the structure of polymer. From polymer you have to draw the structure of monomer. It is very simple to draw structure of monomer. You know this part is alcohol. Look here, OH. This part is alcohol part. Carbon double bond oxygen mean carboxylic acid part. So how to draw the structure of monomer from this? So you just draw this box and we know here it is OH. Box, each side OH because it is alcohol. And this is carboxylic acid. Carbon double bond oxygen. It is related to carboxylic acid. So just draw this type of box. Carbon double bond oxygen OH. Carbon double bond oxygen OH. Okay, so sometime in the past paper you can see this type of structure. From structure you have to draw the structure of monomer. So this is dialcohol. This is dialcohol and this is dicarboxylic acid. This is dicarboxylic acid. This is dialcohol. Okay, so you can answer this type of question this way. And here part B, second question, suggests different uses of this type of polymer. Give different uses of terylene. Uses of terylene. Terylene or Decron used to make ropes, cloths, etc. Terylene or Decron used to make ropes or cloths. Okay, polyester cloths. Okay, these are the different type of uses of terylene or Decron. Next one, question number 6, October November 2007, question number 6. Here one table is given, 4 different type of alcohol. Okay, methanol, ethanol, propanol, butanol. Okay, and here energy, here this different type of alcohol is burnt and energy released, the amount of energy released is given over here. Here questions related to this one. First question, what form of energy is given out? Here what type of energy given? Here we know alcohol or different type of fuels, after burn it produce energy. Okay, here after burning it produce heat. Okay, type of energy produced heat. Second question here, this reaction is exothermic reaction or endothermic reaction? It is exothermic reaction. Burning of fuels, it is exothermic reaction. Burning of fuels, we know it is exothermic reaction. Also here energy change over here given negative sign. This negative sign indicate energy released. Positive sign indicate energy absorbed. Okay. And here third question related to this one, here it is given C2H5OH plus oxygen. Okay, what will be the product? We know alcohol after combustion. After combustion it produces carbon dioxide and water. You have to remember this. Alcohol after reacting with the oxygen or after combustion it will produce carbon dioxide and water. Also hydrocarbon after combustion it will produce carbon dioxide and water. For example CH4, C2H6, after combustion it will be carbon dioxide and water. Also alcohol after combustion it will be carbon dioxide and water. You have to remember this. So look here how to balance this equation, balancing this equation. Okay, so here it is given C2H5OH plus oxygen giving carbon dioxide and water. I told you this after combustion it will be carbon dioxide and water. So here C2H5OH plus oxygen, complete this carbon dioxide and water, CO2 plus H2O. To balance this we have to balance over here. Here how many carbon dioxide? Look here how many carbon this side, how many carbon here, 2 carbon, C2H5. So 2 carbon, so there will be 2 carbon dioxide. Okay, and here how many hydrogen? C2H5OH, here 5 hydrogen, here 1 hydrogen, total 6 hydrogen. So we need here 6 hydrogen. Okay, so here I told you 6 hydrogen, so we need here also 6. So you have to do 6 divided by 2, 3. You have to write here 3. Why here 3? Because H2O, here 2 over here, we have to multiply with this number, 2 times 3, 6. So you just do 6 divided by 2 because of this 2, 3. Clear? Now we have to fill here how many oxygen. Here how many oxygen. So look over here how many oxygen this side, 2 carbon dioxide, 2 times 2, 4. 2 times 2, 4. Okay, 3 H2O. 3 H2O mean, you know, here it is 1. H2O1. If there is no number, mean it is 1. So 3 times 1, it will be 3. I will tell you once again. 2 CO2 mean we are counting oxygen. Here 2 oxygen. CO2 mean 2 oxygen. 2 times 2, 4. Okay. Plus here H2O. Here it is 1. 1 times 3. It is 3. 4 plus 3, 7. 7 oxygen. So we need this left hand side also 7 oxygen. Already 1 oxygen. Do not forget to count this oxygen. Already 1 oxygen here, C2H5OH. So we need 6 oxygen this side. 6 oxygen. I told you before H2O. Because of this 2 we had to divide over here. Same, we need 6 oxygen, O2. Because of this 2 we have to divide 6 by 2. It will be 3. So 3 oxygen. So this is the balancing. C2, I will tell you once again. C2H5OH, 2 carbon. So 2 carbon dioxide. Number of hydrogen 5 plus 1, 6. So 6 by 2, 3H2O. Okay. Because of this 2 we divided over here. Next we have to count total how many oxygen this right hand side. 2 times 2, 4. 3H2O, 3 times 1. Okay, so 4 plus 3, 7 oxygen here. Here already 1 oxygen. So we need 6 oxygen. Because of this 2 we divide over here. 6 by 2, 3. Okay, look here. I will give you one more example how to balance this type of equation. Look here, CH3OH, it is methanol. Methanol, after combustion, after reacting with oxygen, also carbon dioxide and water. Carbon dioxide and water. Clear? Here CH3OH, 1 carbon, so it will be 1 carbon dioxide. Here CH3OH, 3 plus 1, 4. 4 hydrogen here, so we need over here 4 hydrogen. Because of this 2 we have to divide 4 by 2, it is 2. So 2H2O. So we balanced right hand side. Okay, now we have to balance how many oxygen. So you have to count how many oxygen this side. Here 2 oxygen and here H2O mean I told you just consider here 1. 1 times 2. Okay, here 2 oxygen, here also 2 oxygen. Total 4 oxygen. Total 4 oxygen. So we need here left hand side also 4 oxygen. 1 oxygen already over here. So you need 3 oxygen. Because of this 2 you have to divide 3 by 2. 3 by 2 is 1.5. So you just write here 1.5. Clear? So CH3OH, 1.5 oxygen, 1 carbon dioxide, 2 H2O. This is the balanced equation. If you want to remove this fraction, you can write like this, it is correct answer. If you want to remove this fraction, you just multiply complete equation with 2. Okay, so what happened here? 2CH3OH, 2CH3OH plus 2 times 1.5, it will be 3 oxygen giving 2 times 1, 2 carbon dioxide, 2 times 2, 4, 4H2O. Okay, I just multiply complete equation with 2. 2CH3OH, 2 times 1.5, 3 oxygen, 2 carbon dioxide, 4H2O. So you can write this way or this way. This is the answer. Okay. Same question, part 4. Here one graph is given. Okay, and here in x-axis number of carbon atom. Here in the previous table, we discussed the previous question and you saw one table over there, different type of alcohol. Here methanol, ethanol, propanol, butanol. These are the different type of alcohol given. Methanol, you know methanol number of carbon, 1 carbon, ethanol 2 carbon, propanol 3 carbon, butanol 4 carbon. And also in same table it is given amount of energy released during combustion of such type of alcohol. For methanol, amount of energy given, ethanol amount of energy given, same propanol also amount of energy released it is given. But butanol is not given. Butanol you have to calculate amount of energy released during burning of butanol. You have to calculate from the graph. Okay, so look here. You know the amount of energy released for methanol, ethanol, propanol. You have to plot the graph like this. Okay, then you just draw a straight line and it will meet over here. It will meet over here. This is the amount of energy released. Amount of energy released here. This is the amount of energy released for butanol. This is butanol, alcohol with 4 carbon, that is butanol. Okay, so from this graph you will get the amount of energy released, minus 2640 kilojoule per mole. This is the amount of energy released when butanol is burned in excess amount of oxygen. Number 5, here the question asking describe different characteristics of homologous series. We know homologous series mean a series of compounds, they have same general formula, same chemical properties, same functional group, etc. Okay, so here in the table it is given methanol, ethanol, propanol, butanol, alcohol. Okay, they have different number of carbon, methanol, ethanol, propanol, butanol. These are homologous series. These are one homologous series. So from this table you can say homologous series mean a series of compounds, they have same general formula. They have same general formula. They have same chemical properties. You saw over here, they produce carbon dioxide and water after combustion, means they have same chemical properties. Also they have same functional group. All of them consist of OH functional group. So homologous series mean a series of compounds, they have same general formula, same chemical properties, same functional group. Clear? Here question, here next one, part B. Here butanol. Butanol. Okay, butanol, it is alcohol with 4 carbon atom. Okay, so here in the question it is saying butanol. Butanol. Here you know but mean 4 carbon. Here CH3, CH2, CH2. Butanol mean in first carbon there is OH. Okay, this is first carbon. So in first carbon there is OH. CH2, 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 CH3. This is butanol. Okay, the question asking draw another isomer. What do you mean by isomer? Different compound, or you can say different compounds, they have same molecular formula but different structure. Not isotope, isomer. Different compounds, they have same molecular formula but different structure. That is isomer. So this is butanol. you had to draw another isomer for this. Another isomer mean another compound which consists of same number of carbon, hydrogen and oxygen, but structure is different. That is isomer. Okay, so let us see here how to draw isomer for butane 1-ol. This is butane 1-ol because why it is butane 1-ol? Because OH in first carbon 1, 2, 3, 4. OH in first carbon, that's why it is butane 1-ol. Look here, another isomer, 4 carbon. You can draw OH here or here, anywhere you can draw it, but not over here. Okay, when you draw OH here, again it will be butane 1-ol. Okay, so you have to put OH in second carbon, here or here. This is second carbon. When you count from here, again it is second carbon. Remaining all hydrogen. Okay, this is another isomer. Now it is first carbon, second carbon, third, fourth carbon. Okay, it is butane 2-ol. Name of this alcohol, butane 2-ol. How you know this are isomer? You just count number of carbon, hydrogen, oxygen. 1, 2, 3, 4. 4 carbon. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogen, 1 oxygen. Only 1 oxygen. Again here 4 carbon. 1, 2, 3, 4. Number of hydrogen 3, 5, 6, 7, 8, 9, 10. 10 hydrogen and 1 oxygen. So they have same molecular formula. This is molecular formula. Number of carbon, hydrogen, oxygen. They have same molecular formula but different structure. This type of structures are called isomer. Okay. So when you draw the isomer like this, see here OH here first carbon 1, 2, 3, 4. Here 3 hydrogen. Here 2 hydrogen. Here again 2 hydrogen. Here OH, hydrogen, hydrogen. Remember this one and this one are not isomer. This first one, first, second, third. First one and third one are not isomer. Okay. First and third are not isomer because here it is butane 1-ol. Here also, here OH, functional group OH here. So we have to count 1, 2, 3, 4. Not from here. OH functional group over here. So this is first carbon. So here again it is butane 1-ol. So 1 and 3 are not isomer. 1 and 3 are not isomer. But 2 and 3 they are isomer. 1 and 2 they are isomer. So you cannot do 1 and 3. They are not isomer. Clear? Thank you for watching this channel. Please subscribe and press the bell icon for more videos. Thank you.